My original plan to determine if my experiment was successful was going to be based off of the yield and the taste of my product, because of course I am making candy, so I had to taste it. And by doing this, I was hoping to examine the rock candy formations that would develop and to see which solvents out of the sugars would produce the biggest candies, the largest rock candies for me to look at. And this unfortunately was not something I was able to do because, as you can see on all these sticks, there is no product at all. And so this kind of put a kink in my things. So I had to change my standards and ended up changing it to if there was any formation of any precipitate in the, on the sticks or in the jars. And luckily I did have a little bit of precipitate form the bottom of my granulated sugar jar. So basically, in order for me to determine if my experiment was successful, I needed there to be some form of recrystallization of the sugars anywhere in the vessel or on the stick of each experiment. In this experiment, I implemented recrystallization techniques since I heated up a solvent to dissolve a solute and with the hopes of a more pure crystal of the solute to be produced after the solution cooled for an extended period of time. This relates to lots of experiments that we've conducted over the course of the semester, since this is a purification technique which we performed in various different experiments when trying to purify any type of any type of solute out of a solution. And then at the start of my experiment, I also had the ambitious hopes of performing either TLC or melting point evaluation into this experiment, but since I did not have 100% sucrose to use a homemade TLC plate and then conduct thin layer chromatography and compare the RF values of my product to the 100% sucrose, that was not something I can do. And I also did not have the proper equipment to perform a melting point evaluation. If I were to have done that, then I would have done the melting point evaluation of my products, gathered those ranges and those experimental values, and compared those values to the literature of the melting points of 100% sucrose. From here, I would be able to tell if there were impurities present by the range and the temperature at which the product starts to melt at. Over the course of my experiment, a lot was happening on a chemical level to the sugar. At the start of the experiment, when the sugar was added to the hot water, the saturated solution was formed. This solution formed since the hot water dissolved the sugar that was added to it, and in doing so, it broke down the lattice structure of the sugar. Once the saturated solution was formed and removed from the heat source, it began to cool and the recrystallization of the sugars started. As described by our textbook, Organic Chemistry Laboratory Techniques, 2nd edition by Lisa Nichols, recrystallization is a process of purifying a substance, by which the substance is dissolved in a hot solution and then cooled to allow the wanted material to recrystallize out of the solution. This means on a chemical level, while the recrystallization is occurring, the wanted substance tends to selectively incorporate the same particles and exclude impurities into its lattice structure, since this allows the new pure crystals to be at a lower energy than they would be if impurities were present. The slower the cooling of a saturated solution, the more pure the resulting crystals are, since the rapid cooling of a solution favors the formation of a solid, whether or not that solid be the energetically favored product. The idea of cooling the saturated solution slowly so that the crystals may form in the solution with minimal impurities trapped within the lattice structure was explored further by Rodrigo Alvarengas and his colleagues when they looked in the process of crystallization on an industrial level and attempted to look for ways to improve the process. In doing so, they found that the need to cool the crystallization medium slowly was a must, since the rapid cooling of their crystallization medium, due to putting the medium on a colder surface than it was when it was on the heat source, resulted in poor results and had a lot of unforeseen effects, as they put it. If I were to do this experiment again in the future, I would use a higher ratio of sugar to water than I did. I used a 2-to-1 sugar to water ratio since I had read certain recipes that said that would be a high enough ratio in order to have rock crystals form or rock candies form. And for my case, that was not true. So I would change that to a 3-to-1 or even a 4-to-1 ratio of sugar to water, since I think this would actually give me some formation of rock candy. Another thing that I would change is I would attempt to be better prepared with a plan for testing the purity of my crystals instead of just evaluating it based off of the size and taste of crystals that form. I think it'd be a nicer idea to have some form of evaluating the purity, like having 100% sucrose, so I could use a homemade TLC plate and run a TLC evaluation of my product to that, or potentially somehow finding a way to use a melting point evaluation, whether that be to use the melting point rangefinders that we have in the lab or some type of similar device that I could use. And the final thing that I would actually change was I would heat my mason jars before putting the hot sugar water solution into there. After not getting any product, I did some more research into why that happened, and a couple of recommendations was to put your mason jar in a hot water bath to get that warm, so that way when you pour your sugar water that is hot already into that, it's not going from a really hot vessel, the hot pan, to a cold or even room temperature vessel, which is the mason jar. That is something that I did not do, and that is another idea that is explained in the improvement for industrial crystallization process producing of vermiculin paper by Rodrigo and his colleagues, where they did explain that you need to keep the temperature relatively similar when you're cooling it down so that everything can cool evenly. This produces the best amount of product and the most pure products, which is something that I would definitely change if I were to do this experiment again. So if I implemented just a few of these changes, such as the higher sugar to water ratio and the heating of my vessel, the mason jar, before putting in the solution, I think this would give me a higher a higher yield of my rock candies, and it would also give me a higher purity of these rock candies that would form, since of course it would be cooling evenly, allowing the last structures to properly form, and there would just be more sugar available to precipitate out of the solution and form the recrystallization structure.